Alright, here's a harder problem, and I'll walk you through it step by step. In certain African countries, 4% of newborn babies have sickle cell anemia. You can see that I have 4% underlined because that will be an important value in your equation, which is a recessive trait, and the 4% will be the recessive value. Out of a random population of 1,000 newborn babies, how many would you expect for each of the three possible genotypes? And the genotypes are again big A, big A, big A, and little a, little a. So let's figure it out. So before you start figuring out the problem, you should write out both formulas. One of them is p squared plus 2pq plus q squared is equal to 1, and the other one is p plus q is equal to 1. And then you can go into working the problem. So it said that 4% of newborn babies are sickle cell anemic, and that's a recessive trait. So the recessive trait is little a, which would be q squared. And the 4% should be turned into a decimal so you can figure out the problem. So the decimal of 4% is 0.04. So you want to plug that in under q squared. And then, because you know the value of q squared, you can square root that to get the value of q. So the square root of 0.04 is 0.2. So you can plug that in down here and put 0.2 equal to 1. And then you know the value of p right away because 0.2 plus something has to be equal to 1, and that something would be 0.8. So 0.8 plus 0.2 is equal to 1. And then because the value of p is 0.8, you can figure out what p squared is because 0.8 times 0.8 is 0.64. So that is the value of p squared. So you can plug that in under there. And then, since we already figured out the values of p and q, you can automatically plug them in to 2pq. So 2pq would be 2 times 0.8 times 0.2. So then that value should be equal to 0.32 if you multiply it out. And then you can plug that in for 2pq. And if you add 0.64, 0.32, and 0.04 together, it should equal the value of 1, which it does. So then you know that you successfully figured out what p squared, 2pq and q squared are. So after that, there was one more step to the problem. It said that the population was made up of 1,000 newborn babies. So you need to take 0.64, 0.32, and 0.04 times 1,000 to figure out all of these genotypes. So 0.64 is big A, 0.32 is big A, and 0.04 is little a. So 0.64 times 1,000 will give you 640. So that means 640 people of that population are homozygous normal. So that is big A. And then you want to take 0.32 times 1,000 to give you big A, little a. So 0.32 times 1,000 is 320. And that means that 320 people of the population are heterozygous. And then you want to go back and take 0.04 times 1,000, and that gives you the value of 40. So that means that 40 people out of that population are homozygous sickle cell. So 40 people have sickle cell. And then these would be the answers to that problem. So you successfully figured out the genotypes for this problem, and you did a Hardy-Weinberg problem. Congrats.